Have you ever really stopped to think about how we learn things? I mean, not just memorizing facts for a test, but these incredibly complex skills like recognizing a friend's face in a huge crowd, or just knowing how to act in a new social situation. Well, today, we're going to dive into a really fascinating idea, that our mind isn't just one big, general-purpose computer. Instead, it might be a complex system of distinct, specialized tools, what you could call modules. So, here's what we've got on tap. We're going to start by exploring this idea of a learning instinct. Then, we'll look at some real-world examples. Think face recognition and learning social norms. After that, we'll see how a really modern skill like reading fits into the picture, and that'll lead us to the core concept of biological modules. Finally, we'll see how this all comes together into a pretty powerful working hypothesis for understanding the human mind. All right, let's kick things off with a concept from the biologist Peter Marler that really flips the old way of thinking on its head, the learning instinct. Now, I know what you're thinking. That sounds like a total contradiction, right? How can something be both learned and instinctive at the same time? Well, the key here is how precisely it's defined. See, a learning instinct isn't just some vague, general urge to learn whatever's around. Nope, it's a targeted, evolved ability. You can almost think of it like a specialized toolkit that our brain comes equipped with, one that's designed to acquire a very specific type of knowledge, like language for us humans or specific songs for certain birds. It helps us zero in on and extract the right information from all the noise in the world around us. And this idea completely reframes the whole debate. The old view basically drew a hard line in the sand between instinct and expertise. Something was either innate or you acquired it. End of story. But this new view suggests it's more of a continuum. An instinct is kind of like a natural expertise, and an expertise is kind of like an acquired instinct. So this totally changes the question we're asking. We're no longer stuck on, is it innate or acquired? Now the question becomes something much deeper. How do our evolved built-in abilities actually prepare us to learn from our experiences? Okay, so let's look at some real, concrete examples to see how this actually works. How does this whole continuum idea play out with a skill that, we use every single day of our lives, recognizing faces? So here's the big question. Is our incredible ability to recognize thousands upon thousands of different faces an evolved predisposition, a type of learning instinct? Or is it just the result of a mind-boggling amount of practice that starts the second we're born? This debate is just fascinating because both sides have really strong points. The argument for an evolved basis points to a very specific region in the brain, the fusiform face area. If that area gets damaged, the ability to recognize faces is just gone. But the expertise argument is also really compelling. I mean, we get so much practice with faces from the moment we open our eyes, it seems totally logical we'd become experts. This is just a perfect example of a scale that isn't simply one or the other. It exists somewhere on that continuum. And here's another puzzle that fits this model perfectly. Just think about toddlers for a second. They are amazing at picking up social norms, the right way to do things. But how on earth do they do it? Most of these rules are never explicitly taught. So how do they figure out which actions are meaningful, normative ones, and which are just the random behaviors they see all day long? Well, research by Gergely Chibra and George Gergely gives us a huge clue. What they found is that even infants are incredibly sensitive to something called ostensive communication. That's basically when someone addresses them in a really direct, attention-grabbing, intentional way. Infants seem to have this built-in understanding that when an adult does this, the information being shared is important and generally relevant to everyone in their social group. This was shown in this fantastic experiment. An adult turns on a lamp by pressing it with their forehead. Now, when they do it ostensively, looking right at the infant, making eye contact, as if to say, hey, pay attention to this, the infant copies that weird head touch action. But if the adult just happens to touch the lamp with their head without that intentional communication, the infant just ignores the strange method and uses their hand to turn it on. This really suggests they're not just mindlessly mimicking, they are inferring a social norm. And get this, it doesn't even stop there. Toddlers will then go on to enforce these norms they just learned on other people. They'll correct a puppet or another adult who does it the wrong way. This all points to a kind of learning instinct that is specifically for identifying and acquiring social rules. Okay, so face recognition and learning norms are universal human skills. It's pretty plausible they have a deep evolutionary history. But what about something much, much newer in human history? Something like reading. Reading is the perfect example of a recent cultural skill. evolution moves at a glacial pace. There's just no way it could have produced a dedicated reading instinct in the few thousand years we've been doing it. So cognitively speaking, reading is a pure expertise. It's acquired through years of intense, guided practice. It seems like it should be at the absolute farthest end of the continuum from instinct. Or should it? And this is where it gets really interesting. Neuropsychology shows that, even though it's a recent invention, reading consistently recruits a very specific small part of the brain, the visual word form area. And it's located right next to the face recognition area, and it's pretty much the same across different people and different cultures. Now, that looks suspiciously like the kind of dedicated brain area we see for more instinctive skills. So what in the world is going on? Well, the leading hypothesis from Stanislas Dehaene and Laurent Cohen is something called neuronal recycling. The basic idea is that a new cultural invention like reading doesn't just create a new brain area from scratch. Instead, it co-opts or recycles an existing part of the cortex that already happens to have the right properties for the new job. In this case, an area that was already good at recognizing small, complex shapes. And this suggests a brilliant kind of coevolution. It's not just that our brains adapted to reading, writing systems themselves actually evolved to be learnable by our brains. Over time, cultures discovered and refined the symbols that were the easiest for this specific recycled brain area to process. So in a way, our culture literally shaped itself to fit the pre-existing architecture of our brain. So we've looked at skills all along this continuum, from something like face recognition all the way to reading. What do all of these mechanisms, these specialized tools for thinking, really have in common? Well, this brings us right to the core concept that ties all these ideas together. The module. In biology or engineering, a module is simply an autonomous component of a larger system. It has a specific job to do, it has its own procedures for doing that job, and it has its own history. So the face recognition system, the norm learning mechanism, even that recycled reading area we just talked about, they can all be described as modules. And we should be clear, when we talk about a module in a biological sense, the concept is incredibly broad. It's not just one thing. A module can be as big as the entire brain or as tiny as a single neuron. It can be something physical, like an elephant's trunk, or it can be a behavior, like the way a cow ruminates. It can even be something that only shows up in certain situations, like a callus forming on your skin after a lot of friction. Now, you'd think applying this straightforward biological concept to the mind would be a no-brainer, but it's actually been surprisingly controversial in psychology and philosophy. So why all the debate? Well, a lot of the controversy goes back to the philosopher Jerry Fodor and his highly influential book from 1983. He proposed a very strict, very narrow definition of what a module is, and based on that definition, he argued that only input systems, like our senses and language, were modular. He claimed that our central processes, like reasoning and belief formation, were definitely not modular. The view we're exploring here is much broader, and it's much more in line with biology. A cognitive module is simply any biological mechanism that serves a cognitive function. And this view allows us to include things like the reading module, which just wouldn't fit into Fodor's narrow little box. And using this broader view helps us correct two huge common misconceptions. First, modularity does not mean innate. As we just saw with reading, a culturally learned skill can absolutely become modularized in the brain. And second, modularity does not mean the mind is rigid. In fact, it's pretty much the exact opposite. In biology, having a system of specialized articulated modules is precisely what gives complex organisms their incredible flexibility. Okay, so where does all of this leave us? Well, it all points toward a really powerful working hypothesis for understanding the brain, seeing the mind itself as a modular system. The idea that our mind is this complex articulation of many different modules, some evolved, some recycled, some big, some small, it provides a challenging and powerful framework for cognitive science. And it leaves us with this crucial, really exciting question for future research. How can all of these individually fairly simple, specialized parts combine to create the astonishingly complex and flexible intelligence that we experience as human consciousness?